Okay, so these are the ionic bonds notes, and this will be an Edpuzzle, so you will have some questions to answer. Ionic bonds, a bond formed between a metal ion, a cation, and a nonmetal ion, an anion. Nonmetals make negatively charged ions, metals positively charged ions. Compounds have a name when that usually ends in IDE. So calcium hydroxide, sodium chloride for salt. Atoms, for the octet rule, atoms will combine to form compounds in order to reach 8 electrons in the outer electron shell. Atoms with less than 4 tend to lose electrons. Atoms with more than 4 electrons tend to gain. There are some exceptions. Formation of ions. So 3 protons, 3 electrons, 0 net charge. So this is like this is a lithium metal ion. 9 protons, 10 neutrons, net charge of 0 because you have 9 protons and 9 electrons. So the metal loses the 1 electron so that it can have a full shell, and the anion or the nonmetal will gain 1. So losing 1 gives you a positive because there are less electrons than protons, and the negative ion or the nonmetal because it's gained 1. So positively charged ions. Metals form cations. So plus, there's the Lewis dot right here. Lithium has a +1, beryllium 2 electrons in the outside orbit, +2, boron +3. Cats have pause. Cations are positively charged ions. Negatively charged ions. Nonmetals form anions that gain electrons. So nitrogen has 5 electrons. So, oops, let's go back on that one. So negatively charged ions, so it gains 3 to make 8, so that's a -3. Oxygen has 6, it gains 2, so makes it -1. Fluorine has 7, gains 1 to make it -1. So the oxidation number we'll be talking about, that has to do with losing and gaining electrons and their ionic charge. Helpful to determine how atoms will interact with a bond. Remember, when you gain negative electrons, you become negative. When you get rid of negative, lose electrons, you become positive. Okay, so here's the oxidation number, +1. So we have 1 electron in the outside orbit, so we know it's going to be a +1, +2 for the second group, +3 for group 13, and then carbon can go either way, negative or +4, but nitrogen needs to get 8, so -3, -2, -1. Right, what ion will the following elements create? So beryllium is a metal, so it's going to be a plus. Phosphorus is a nonmetal, it's going to be a negative. Aluminum, so once you figure out if it's metal or nonmetal, potassium, So this will tell you whether it gains or loses, and then the charge on those. So beryllium, looking at the periodic table or the oxidation number, +2. Phosphorus is a nonmetal, -3. Aluminum, metal, +3. All right. So writing in the ionic formula, we use this crisscross method. Okay, so we put the oxidation numbers up here. So sodium, looking at the periodic table, has 1 electron, so it's +1. And nitrogen has 5 electrons in its outer shell, and it wants to gain 3. So it's got to make that -3. So we use those numbers. We don't worry about the charges at this point. So what we do is we make a subscript, and we put if there is a 1, we just omit it. But if there's a 3, we put 3 here. So we don't put the charge in there. So it's Na3N. So that means there's 1 nitrogen and 3 sodiums. So calcium has a +2, so we cross multiply, make the phosphorus 2, and the -3 becomes a 3, so we have calcium phosphide. All right, formula for writing. Okay, so the crisscross method. All right, so beryllium has a 2+, and fluorine has a -1, has 7 electrons. So we write that as 1 and 2, but because we don't need the 1, we just write this as BeF2. All right. So boron and sulfur, you can see what they've done here. They put the sulfur is a -2, and boron is a +3. So we cross those like this. That's how we get our numbers. Aluminum has a +3, oxygen a -2. Cross those over. So we've got calcium +2, nitrogen -3. All right, so the first word, name of the element. Okay, so we're going to call, in the second word, we drop the ending and put IDE in it. So calcium oxide. So this is potassium. I don't know if I spelled that right. Potassium bromide. Aluminum oxide. So we just add that IDE on the oxygen. Just start with brom and then ide. All right, here's your answers. Chloride, you can see, just add the IDE at the end. High melting points, ionic bonding properties, high melting points, high boiling points, hard and brittle. Dissociate, that means it breaks apart, the ions break apart in water, and they conduct electricity when dissolved in water. So if you add salt to water, it'll conduct electricity. Salt is sodium and chloride ions.